In this video, we will see how to drive a 7-segment display using 7447 IC. So here is the 7-segment display which has been explained in the previous part. So now let's see the 7447 IC. So it is a 16-pin IC where it has 4 input pins and 7 output pins. Now first we will see how is this connection made from IC to the 7-segment display. As you all see from on the screen that each pin on the IC represents the corresponding pins on the 7-segment display. 13th pin here represents A bar, which means it should be connected to the A pin on the 7-segment display. 12th pin to the B pin, 11th pin to the C pin on the SSD, 10th pin to the D pin on the SSD, 9th pin to the E pin, 15th pin to the F pin, and 14th to the G pin on the 7-segment display. VCC and ground will be connected to 5 volts and ground from the Arduino board. Now we'll see what are the input pins. So here are the input pins A, B, C and D, which means that it takes the input, that is the logics from the A, B, C, D, convert it to the binary, that is convert it into the decimal, and that decimal representation correspondingly it will make the logics on the 7-segment high and low, and it will be displayed on the 7-segment. So how are these connections made? We will see it. A pin, that is the 7th pin on the 7447 IC, is connected to the 2nd pin on the Arduino board. B pin connected to the 3rd pin on the Arduino board. C pin, that is 2nd pin on the IC, to the 4th pin on the Arduino board. 6th pin on the IC to the 5th pin on the Arduino board. Here we can see the corresponding pin numbers on the port D. So the Arduino pin 2 represents the 2nd pin in the port D. Arduino pin 3 as the 3rd pin in the port D. 4th pin as the 4th pin on the port D, and 5th pin represents the 5th pin in the port D. Now we'll see how the numbers will be generated. On what logic the numbers are generated. So here is that representation. So here you can see that we all know that the binary representation of number 0 to 1, and these are displayed here. So which means that on this IC, the A represents W, B represents X, C represents Y, and D represents Z, which means A is the least significant bit and D is the most significant bit. So for example, we will see the generation of number 4. So the binary representation of number 4 is 0, 1, 0, 0. So which means we should pass the logic 1 to the 2nd pin, that is C, which will then generate the logic, which will generate the number 4. So number 4 means it should have these logics on the 7-segment display. So correspondingly it will make the A, D and E pin high, that is like 13th pin, 10th pin and 10th pin and 9th pin as high, and keeps rest on the 0 logics, so that the corresponding values will be given to the 7 segment display and it will generate the number 4 on the display. We'll move towards the programming part now. Before we go, I'm using the port D. So we'll see that port D data direction. So port D data register. So we are using the second, third and fourth pin on the port D. So we need to set the third, fourth, fifth and sixth bit as high to use the port D. And here is the data direction register. Okay, let's move towards the programming now. So open the terminal, type Genie. Here Genie is my editor. So here is the port 1 and port 2. So take the new script here and start writing the program. I'll include the header files first. #include avrio.h int main void. And once my main is declared, this embedded C is also similar to the Arduino IDE programming, where it has two parts, the setup part and the looping part. In the same way, this also has the direction mode, that is the data direction, and then the loop part, that is while loop. So first we will set the direction, that is which pins we are going to set it as an output pins. So as we are using the second, third, fourth and fifth pin from the port D, so I'll set it as data direction register of the D port as DB001111 and 00, which means that second to fifth pin will be configured as an output ports. So once this is done, we will jump to the looping part. In here, PORT port D equals. So we have to say which pins should be high, so that we want to generate the particular number. As we can see here, we will write a program to generate the number 7. The binary representation of 7 is 0111. So we need to pass the same values on the port D. So 0B00. The binary representation is 0111. 00. So I'll return 0. So that's all is the program. We just need to write the binary value. We just need to write the binary value of a decimal number. It will automatically generate the required 7 segment displays as high and low, and it will be displayed on the 7 segment display. So I'll save the file. I have already created a directory to make this embedded C programming. I'll go there and I'll save it in the same directory. I'll save it as ssd driver.c. So go to the terminal, and I've already told you that to compile the embedded C programs we need a make file. So I've downloaded from the IITH TLC website and kept it in the same directory where I've saved my all other files related to embedded C. So I'll move to the directory there, and after that I'll type make f name equals ssd driver and hit enter, and we can see that the program has been successfully flashed into the Arduino board. And we can see that a number 7 is being displayed on the 7 segment display. So we will take one more example, as we know that this part in the program should be changed to change the numbers. So we will see the number, how to display the number. We'll see 5, how to display a number 5. So what is the binary representation of 5? 0 1 0 1. So we should pass 0 1 and 0 1. Save this file, go to the terminal in the same directory, like where both makefile and SSD driver program is saved. Just type make fname SSD driver, hit enter, and we can see that number 5 being displayed on the 7 segment. So in this way we can modify the program, that is like these 4 bits we can modify according to this table, and we can generate the required numbers on the 7 segment. We'll start the connections now. First we'll connect the 7447 driver IC to the 7 segment display. So let's start this. First we'll connect A, that is the second pin, to the 13th pin on the IC, that is this is a 16 pin IC, so 8, 9, 10, 13 pin. B pin on the 7 segment display to the 12th pin on the IC. C pin to the 11th pin. D pin to the 10th pin. E pin to the 9th pin. F pin on the 7 segment display to the 15th pin on the IC. And G pin from the 7 segment display to the 14th pin on the IC. Once this is done, we will connect the inputs, that is ABCD, to the Arduino board. So A is the second pin on the A is the 7th pin on the IC, that is 1, 2, 3, 4, 5, 6, 7. 7th pin on the IC to the second pin on the Arduino board. Next we'll connect B. B is the first pin of the IC. So first pin of the IC to the second pin on the Arduino board. Next we'll connect the C, that is second pin on the IC to the fourth pin on the Arduino, and we'll connect the D, that is 6th pin on the IC to the 5th pin on the Arduino board. We'll make connections for the ground. So ground, I'll make this entire line as ground. Then I'll connect the COM pins of the 7 segment display, and from there I'll connect to the another line, and from here I'll connect it to the VCC, that is 5 volts here. Then 8th pin on the IC to the ground here, and 16th pin will go to the VCC, that is this right. connect the register here. Next, I'll connect my Arduino to the board. I'll just go to the terminal and dump the code, and we can see that number 7 is being displayed. Next, we'll display the number 5. So I'll modify the program accordingly and I'll dump it, and we can see the number 5 being displayed on the 7 segment display. Thank you.